Hello everyone, this is Debabrata once again, and today I'm planning to take the second part of our recursion class. So as I mentioned in the first class, I have already segregated this recursion class into three parts. So in the last class, we have checked the basic or starting recursion and where we have used all the function with void type. But today I'm going to use the functions which will be returning something, and this will be the part two of our recursion classes. So as a prerequisite, obviously you have to go through the first recursion class, and obviously you have to revise all those things. We have a nice exercise for this, so you can practice all those things as well, but this time not using the void type recursions. Okay, I'll be showing you what I'm trying to mean about the void type and return type of recursions. So without wasting time, if I quickly jump into the topic. So the first topic is for application programs with return type of recursions. So if you can remember our last class, obviously it is must needed that you need to revise the first class of recursion. Okay, otherwise it will take a longer time for us to understand this topic. So if we have already revised that class, now this program will be easier for us to write, enter a number and find its factorial. If I write the program in front of you, let me go to Blue Java. You can use any of the compilers as per your wish. So suppose I am taking one input, and if I quickly type the program that we have done last week, suppose let me introduce some program like math, and I am sending in, and I'm sending another variable called 1. So if I'm sending both of them, and suppose inside the void method, if I'm taking two variables, int I and int suppose product, so I will iterate till the value of n becomes 1. And every time what I'm doing, I am calling the math function once again, and with n minus 1 and p equals to p into n. So when everything will be done, what I'll be doing, I'll be just printing the value of p. So value of p will be holding the factorial of the number n. If you are not able to understand this program, just revise the first class. I am just repeating the whatever the programs we have done in a first class. Today I'll be showing the same program with return type recursion. So here I am using void. That means it has been done in the previous class. The exactly same program I will do today. All the programs that I will do today will be just will be the same what I did in the last class. Okay, so for a detailed level explanation, you can just go through the last class. So if I enter 5 just to check, yeah, if it is returning 120 or not, yeah, I can see it is returning 120 as a factorial. So now this time, what I'm trying to do, I'm trying to return something from this function. I'm trying to return something. So if I'm trying to return something, the answer will be an integer. So it will be returning int. And here, obviously, I have to print that value. If it is returning something, I have to print that value, because I will receive some value here, and I'm trying to print that value. So here I'm trying to print the factorial. So in this case, I can skip sending the product as 1, because anyhow that will I receive in my main function via this math function. Okay, so if I show you in detail what will happen in this case, suppose I'm receiving 5 here, and what I'm doing, when it is greater than 1, I will calculate if I will take one new variable called f, and f will be calculated like n into math of n minus 1, math for method say, and at the end I will return f. And in the else part, let me check what can I do. So what it is doing, whenever I'm calling math 5, suppose user has given math 5, so obviously it will receive n as 5. Let me write it somewhere. Let me show you the dry run. So obviously it will receive math 5 here, n equals to 5, suppose. And here, obviously, n is greater than equals to 1. You can see n is greater than equals to 1. So what it will do, f equals to 5 into math 4, obviously n minus 1. And after that, it will try to return. So return will send this value of f, return f will send this value of f into the main function who called math5. But obvious reason, I'm not able to calculate this value here. I'm not able to calculate the value of math4. Once it is being calculated, then I can return. So it cannot, the program cannot reach to the line number 2. The control will never go to the line number 2. From math4, it will again try to call the same function, but this time it will be math n equals to 5, means it will be received by the math function with n equals to 4. So what will happen in between? In between, again it will try to calculate f equals to 4 into math3, obvious reason, and again it will try to return the value of f. Okay, let me delete these brackets because it is a dry run, so I can make it simple. There is no nothing is mandatory that I need to give some brackets and all. Anyway, so math n equals to 4 will call, if I put it below here, math4 will try to face these two lines. Okay, again math3, obviously math3 is not being able to, means I cannot able to calculate that math3 here. So it will call the function once again, and it will again inside math3, it will again try to call f equals to 3 into math2 and return f. Obviously the same type of code is iterating. We have already learned that, but here we are trying to return something. In the last class we haven't returned anything. So inside math2, what will happen? It will do 2 into math1. So again, it will try to return the f, but unfortunately, math1 is not decided yet. So inside math1, what will happen? It will be like f equals to 1 into math0. So, and it will try to return f. So enough is enough. So we have already reached to 0. So obviously we do not need to calculate the 0. So that's why I have written n greater than equals to 1. So whenever it reaches to 0, it will go to the else function, else statement, and here I will simply return 1. If I return 0, everything, the product will be 0, because if you multiply anything with 0, it will become 0. So that's why in case of product, in case of multiplication, I will return 1. In case of summation, I will return 0. So if math 0, and inside math0, obviously it will first return some finite value, that is return 1. So return 1 will be returned to math0. So here I will get the value of 1. 1 into 1, it will be 1. I got a value of f. That's why I can return the value of f. That means return 1 to the calling function. So calling function was math1. So it will receive the answer 1. So now 2 into 1, I can calculate the value of f here, and it will be f equals to 2 into 1 means 2, and I can return 2 to the calling function, and the calling function was math2. So if 2 is returned there, then I can calculate the further the value of f, and that will be 6, and I can return 6 here into math3. So it will receive 6, and 4 into 6 equal to 24, and I can return 24 to the calling function, that was math4. So at the starting, when I have written 5 into math4, the value of math4 was unknown, but somehow calling the function itself, I can have the value of math4 now, and it will be 24. So I can calculate 5 into 24, and that is 120. And now finally I got some finite value inside f, and I can return the value 120 to the calling function. And here for this calling function was from the main function. So in main function, I will get 120. So it is an iterative process. You have to return something again and again and again, and I will get that value. And for this chapter, for the first time, you have to think wisely, because all the previous chapters, it requires only practice. But in this chapter, you have to put some of the intelligence. Obviously, those chapters also require some intelligence, but here you have to be cautious of writing at the time of writing those return statements. So now if I run and if I enter 5, it should return me 120. Here it is returning to the main function. I am printing the value from the main function. If you are not able to understand, I will request you to just go through what I have done once again. Just go back 5 or 10 minutes back and just check the program I have done once again. And if you are able to understand a bit, then we can proceed to the next program and we can check how we can solve it using return type function, because this program we have also done that in our first class. So first, let me do one thing. Let me copy this function somewhere because it might be required later. So let me write factorial and let me write this function. So now let me do that sum of digit, SOD, suppose. So sum of digits, we have done that using void. Let me do that using void first. So I will enter one number, and after that, I will call the function called sum of digits, say, and I will send n with 0, and 0 will store the value of sum. So here, obviously, I will use first void. Let me show you the program with void that we have done in our last class. Just revise a bit. So until the value of n is greater than 0, what we have done in our last class, it was simply calling SOD, or the name was math at that time, but for the time being, I can write SOD, comma, function name doesn't matter at all. And here I can write s plus in %10. If you can remember, we have done that. So when I will go to the else function, what I will do, I will simply print the value of s. So today I will take the similar approach. Let me do that, but first, let me first print the value of s. So whenever everything will be done, it will print the value of sum. So if I run this program, suppose enter the number of the elements. So, oh, it is printing the wrong statement. It should be enter the number. So suppose I have given 145. So it should print 10 because 1 plus 4 plus 5 is 10. So sum of its digits. So now if I want to make this program, I have already explained the program mechanism of void type recursion in our last class. Again, I'm saying just go to that class and revise that class and you will be able to understand how I am solving it using void. But today, my focus is to solve the same thing by returning something so that I can simply print the answer here in the main function. So I want to simply print it here, SODN. So it will get some value and it will try to print something. So again, everything will be same, but I will be sending only one value. So I do not require any sum here. So until n greater than 0, what I will do, I will take a variable called s, which will hold the sum like in %10 plus. Anyhow, the logics are somehow being same and SOD n by 10. So I have to write it wisely. I'm explaining. You can see both the lines are same, almost same. Anyhow, I will delete that part and I will explain what I'm trying to do. First, you need to check all these programs, and then at the time of exercise, you have to think how can it be solved. If you are not able to solve it, you can ping me, or you can just write a comment in the comment section. You can send me a mail. I will try to explain all of those exercises. Even I can share the exercise solution as well. So here, what I'm doing, let me explain. So suppose I have sent, let me show you the dry run. I have sent SOD 145. Say what it will do. N is greater than 0 means 145 is greater than 0. What it will do? It will simply try to calculate the value of s. That is 145 %10 plus it will call the function SOD once again, and that will be 145 by 10. So, and after that it will return the value of s. So obviously we cannot return the value of s because we do not know what is the answer of this part. 145 by 10, that means 14, and 145 %10 means it is 5. So I cannot get a value from this calculation because we do not know the meaning of SOD 14. So from here, it will call the function once again with a value of 14. So 14 is greater than 0. You can see 14 is greater than 0. Then it will try to calculate the value of s again. So what will be the value of s this time? S equals to 14 percentage 10. Anyhow, the logics of void type of recursion, the logic of for loop to get it solved, everywhere the solution will be same. It will be n percentage 10, and next time it will call n by 10. So if you are able to understand that, everything is solved, means you are in a good condition now. So, but let me explain the full dry run. So it will be SOD 14 by 10. Anyway, again, I cannot calculate the SOD 14 by 10 so that I cannot return the value of S here. So SOD 14 by 10 means it is 1.4, and we cannot store 1.4 in an integer variable, so it will be SOD 1. And 14 percentage 10 means it will be 4. Hope you can remember our first class, chapter 1 in Java. So again, why I have written 14 percentage equals to 4. So it is just a reminder. So SOD 1. So SOD 1, obviously, n is greater than 0 means 1 is greater than 0. Then what will happen? S equals to 1 percentage 10 plus SOD 1 by 10. So again, I cannot calculate this value so that I cannot return. So it will be pending in this step. So 1 by 10 means it is 1 by 10 means 0.1. That means 0 actually in integer. 1 percentage 10 means it is 1. So SOD 0, it will call the function once again. And inside this function, it will go and it will check 0 is greater than 0. Answer is no. So at the time of sum, at the time of calculating sum, I will simply return 0. That's all. If I compile, and now if it returns 0 somehow from this step, so SOD 0 will receive 0. So 1 plus 0, I'm getting, for the very first time, I'm getting a finite value. It is 1. And I will return 1 to the calling function. So who called this function? It is SOD 1 from here. So it will receive 1. And I can calculate 4 plus 1, 5. And I can return 5 into the calling function. Who called this part? It is SOD 14. So SOD 14 will receive 5 at first. So 5 plus 5, it will be 10. And I can return 10 to the main function. And in the main function, here SOD 145, it will receive the value of 10. And if I compile and if I run, so by this way of recursion, I can write 145 and I should get 10 as output. Yeah, I'm getting 10 as output. So this is the way of calling the function. Almost it is same, but yeah, you have to write your codes very wisely. So let me copy this program here. Still, if you are not able to understand the logic, now you might be thinking, yeah, I'm able to understand the logic, but how can I write the program by myself? Obviously, after practicing, it will be okay for you. It will be smooth for you. Obviously, if you can, if you just look back, whatever we have done in our journey, the array, matrix, for loop, functions, everything will be seemed like okay. Everything will be seemed like okay. It is now everything is okay. But at that doing the chapter of matrix, you might think, okay, matrix is the hardest thing in the world. But now it is quite okay for you. So recursion will be also smooth for you if you practice few of the exercise, few of the programs by yourself. Obviously, I will be there to help you. Just let me know if you are getting stuck somewhere. Okay. But for the time being, just see the program and try to understand all those logics. Okay, how I'm writing those programs. So suppose the next program is enter a number and find if it is prime or not. In case of prime or not, we actually do not have anything to return. So first, again, let me do this program using the prime function. Suppose let me use a function called prime. And what I will send n and 2. If you can remember, we have done that in the last class. So again, let me show you the same program using void first, then I will convert it into int. So int return type. So int n and int I received. Inside n, suppose I have sent 7, and inside I, suppose I have sent 2. So what will happen until I less than n? To understand this program we have done, because we are doing the program in void style. So we have done this. That means we have done this in our last class. I will just request you to go through that program. I have already explained. So without wasting time, if I run and if I write this part, so if n is divisible by I will show prime. And if it is not divisible by I cannot come to any conclusion. So what I need to do, I need to call the function once again with n and I plus 1. And somehow if I meets n somehow, so it will go to the else part and it will simply print that the value you have inserted is prime. If I run, okay, suppose if I run, yeah. Okay, it should work. So if I compile and let me execute this program of prime function. So if I enter 7, it should react like it is prime. Yeah. So you can see how I write the program. So now the time to call it using the return type function. So obviously I will try to print whatever I got. So in case of prime, I will either get true or false. Either I will get true or I will get false. So here in case of prime, you have to send the value 2. Otherwise it is not possible to call. So here actually there is nothing to calculate. There is nothing to calculate. In sum of digit, we have calculated something. In factorial, we have calculated something. But in prime, we do not have any calculation here. So what should I return? Obviously, I just need to return true or false. So in this case, what will I do? In case of println, I will just return. Sorry, I have written it wrong. It should be not prime. If the number is divisible by something, it should be not prime. Sorry, my mistake. Anyway, so instead of printing not prime here, what I will do, I will simply return true, return false, because the value I have given that is not a prime number. So I will try to return false here. And instead of printing prime, what I will do, I will simply return true. If you do not have anything to do, if you do not have anything to calculate, simply try to return false and true. If you are able to write the recursion program with void, now suppose you have changed that to any return type. Suppose user is in the question it is written like you have to return the value and you have no way to calculate. Simply whenever you are printing yes it is prime or yes it is Armstrong or yes it is something, at that part just return true. And whenever you are printing no it is not prime, no it is not Armstrong, no it is not some number, so in that place return false. Now obviously if I compile I will get another error. What will be the error? It is saying missing return statement. Yeah, because in this part I'm not returning anything. In this part I'm not returning anything. So from every part it should return something, but this part is not returning anything. That's why it is saying missing return statement. So what to do in this case? Simply write return in front of that. In the exercise you will be getting some of the problems like this where you need to return true or false. Just try those problems using the same thing. Do not think anything, just write return in front of the function and that will be pretty much okay, believe me. Okay, so whenever you are returning true or false or you are returning boolean values or you are returning 1 or 0, simply return 1 or return true in place of you are printing yes. When you are printing no, in that place return false, and in all other places just write return. So what will happen? Let me show you first, and let me first run this program. Let me first run this program. So if I run and if I enter 7, it should print true because it is prime. And if I enter 9, so it should print not prime. If I enter 9, it should print false because it is not prime. So what I'm doing, if I show you the dry run for prime, what is happening? First, I am calling prime 7,2, obviously. So what it is doing, first it is going into inside the function. If I less than n means 2 less than 7, yes. 7 is divisible by 2, no. it is saying return prime in that thing. Let me write return prime 7 and 3. But I have nothing to return here. So obviously this value I do not have. So that means it will call again. Prime 7 by 3, again 7 is not divisible by 3. So it will return prime. It will execute that highlighted line. You can see that line is already highlighted. So that highlighted line will be returned. So again, I do not know the value of prime 7, 4. I do not know what is prime 7, 4. So it will further call the function. So return prime 7, 5. So obviously, again, I do not know the meaning of prime 7, 5, 7, 5. So how can I return something when I do not know the value? So next turn, it is no 7 is not divisible by 5. So it will execute the line return prime 7, 6. So obviously, again, we do not know the meaning of the line return prime 7, 6. So obviously, it will call again and it will execute this line return prime 7, 7. So it will keep executing and executing and executing. So when I call prime 7 and 7, so I is no more or less than n. So I will go into the else statement and it will return true for the very first time. So inside prime 7, 7, return true will be executed. So where it will return? Obviously answer is return true to the function prime 7, 7. So it will receive a value true. So now it will again return true. As I receive the value true, it is a Boolean value true. So I will return that value to the calling function, that is 7, 6, and it will receive the true value. And again, I will return that to the calling function, that will be true. So it will return again to the calling function. So prime 7, 4 means true. True is a value. Okay, it is a Boolean value. You might feel it weird, but again, it is a value. It is not integer, it is not string, it is Boolean. So it is a value. So I got the value. So I can return that into prime 7, 3. So it will be true. Again, return true will be returned to the calling function. And that was the function from main function. So main function will receive true. And here in the main function, you can see the value like true. So after doing 3 programs with this return type, I hope you are feeling good. You are able to understand a bit, I guess so. So if I show you another dry code, what will happen in case of if I write prime in 9, 2, what will happen in that case? So prime 9, 2 will just first enter into the function and it will say, okay, 2 is less than 9. 9 divided by 2? No. So it will call return prime 9, 3. You can see here. So again, 3 is lesser than 9. Yes. So 9 is divisible by 3. Answer is yes. So it will say return false. So I got a perfect value. I got a finite value. So prime 9, 3 will return false. So obviously it is a value and I can return this false to the calling variable, calling function. So here I will receive false and return false will be returning that value inside the calling function. So that is prime n, 2, that will also receive false. So somewhere you need to get a finite value. So here in case of 9, false is being returned from this part. In case of 7, in case of when I have given input as 7, the true is being returned from this part. And iteratively, it will be returning to the calling function. That function will return the value to the calling function. And accordingly, I will receive the value inside the main function. Because from here, I have actually initiated the process. I have actually called this function from the main function itself. So I will receive the final value inside the main function. And that is the logic of return type of recursion. So let me copy this program again if I might require that later. So let me copy that anyhow. So if you are still not convinced that I will not be able to solve this program, let me do another new program this time. Enter 2 numbers and find the HCF. That I have not done in the last class, and I'm not going to show that using void. You can try that. It was in the exercise. So suppose let me called two values, int x and int y. I forget to change the print statement. It is still enter number of elements. It was wrong actually. I have to print something logical. Enter two numbers. That will make some sense. So int xy. So now let me do something like HCF. Let me take a name of that function like HCF, a meaningful name, and I will send x and y both. So what will happen here? Obviously, I will call like HCF, and let me write the same variable name. To avoid the confusion, I'm using the same name x and y, and I'm returning integer. The final answer will be returned as integer. So what should I do? If you can remember the for loop we have done for HCF, we have taken the similar approach. If the value of x is divisible by y, simply I will return y. If you can remember that. Just try to understand. If I have sent, sorry, I have to write x percentage y equals to 0. Suppose I have sent 60 and 30. First, you need to be very clear with the mathematics. With the mathematics of HCF. The mathematics of HCF is saying it is the highest common factor. So that means if I send 60 and 30, that means 60 is divisible by 30. That means 30 would be the HCF. Simply 30 would be the HCF. Okay. So I can write this thing. So if x is divisible by y, it will simply return 0. If not, then suppose I have entered 60 and 36. So 60 is not divisible by 36. So the next round, I'm going to check. I'm going to divide 36 with 24. That divide approach of HCF, if you can remember. I mean to say, if I quickly try to draw. So suppose 60, I'm dividing with 36. 60 is not divisible by 36. That means in the next turn, what I do generally, 36, 1, 36. So I always take the remainder. If you can remember the logic of HCF, I got the remainder here as 24. And I try to divide 36 now by 24 itself. Okay. And I got the answer as 12. And next turn again, I will try to divide 24 by 12. So our remainder will be our next y, if you can remember. And our y will be, in the next turn, it will be x. So this was the mathematical logic. And at last, 24 is divisible by 12. So 12 is our HCF. So whenever x is divisible by y, y will be our answer. So here, what I can do, I will return, let me write it in a smart way. I will return the HCF, and the next turn, what I will call, it will be y, comma, x percentage y. Sorry, x percentage y. Because the value of y, that is 36, that will be considered as x next time. The value of 36 will be considered as x for the next time. So in place of x, I'm sending the current value of y. And in place of y, I am sending x percentage y. Means 60 percentage 36, that is 24, and I'll be sending 24 in place of y. And in the next turn again, I'll be sending y in place of x. That means 24 I'll be sending in place of x. And the remainder of 36 and 24, that is 12, I'll be sent in place of y. And in that turn, 24 is divisible by 12. That's why it will return the answer as 12, because I have written y. So what will happen? Let me show you in a dry run again. Let me delete this calculation. So suppose HCF, I am calling the function HCF with two values, 60 and 36. So obviously 60 is not divisible by 36. So it will go into the else statement, and it will try to return 36 the value of y, and 60% is 36, that is 24. So obviously next turn 36 is not divisible by 24. Again, it will go into the else statement. You can see 36 is not divisible by 24. So it will go into the else statement and it will try to return y, that is 24. And here 36 percentage 24, x percentage y. So the value will be here 36 percentage 24 is 12. So the next turn 24 will be received as x, 12 will be received as y. So this time x percentage y equals to 0. So I will be returning y. That means here inside this function, I will return 12. So return 12 to where? Return 12 to this part. So here, obviously, I forgot to write the function name. So this part, this function will receive an answer like 12. So now this return 12 will be sent to this function. And this 12 will be sent to this function. And this function is being called from the main function itself. Okay, so got the idea? So if I run this program from the main function itself, what will happen? Let me check. So if I enter two values as 60 and 36, it should return me 12. Yeah, it is returning. So that means it is working fine. So we have done 4 programs of recursion. So let me copy that one as well here. If it requires later, I can reuse that without typing it once again, without wasting the time. So if you are still not able to understand, I will request you to go through these programs once again. Try to type those programs by yourself. And still, if it is not, you are not able to understand these programs, just let me know in the comment section. I will try to get in touch with you. Okay, somehow. So I will try to put more examples, or I try to make you understand what happened here. So otherwise, let me go into the topic 2. So topic 2 is very simple. It is saying about tail recursion. So what is tail recursion? So, okay, let me take the first program. Okay, it is saying enter a number and find its factorial. So if I go to the factorial program, if I copy that, luckily I have copied, otherwise I have to write the programs once again. In some classes I missed to I missed to take a backup of these programs. So yeah, factorial program is already working, I think. Okay, yeah, it was in a working state. So I hope if I run, it will work. So tail recursion is saying, do not store your calculative value, whatever will be the calculation, do not store it here. What I am doing here, I am storing the calculation inside the variable f, and after that I am returning that variable. But experts are saying, or some programmers are saying, it is something like a childish thing. It is like a childish thing. Do not store the variable, do not store the value inside the variable f and then return f. It is not good. Instead of that, directly return the value. So this part will also work. So you are calling a function, you are calling another function at the line of return, at the return line. So this part is being called, this approach is being called a tail recursion. Now you might be thinking it is very tough, you are not able to understand. So I want to say you something, like in the last program of HCF, I have done the same. So unknowingly, we have done the same thing. You can see in the return line, I am calling the HCF function. Either you can call it earlier or you can call it at the return line as well. If I can remember, I'm doing the same thing in case of prime number as well. Yeah. At the last line, when I'm supposed to return something, at the last line, where I'm supposed to return something. So without returning, I am calling a new function. So if you are able to understand at that part, it is same here as well. Just the name is being called as a tail recursion. Because if you are calling some function at the end line, where you are supposed to return the final value, and instead of sending the final value, you are trying to call another function, that is being called as a tail recursion. It means you are doing the things at the last, means as a last part, you are calling the function, you are calling the recursive function. At the tail, you are calling, means at the end, you are calling. So that's why it is being called as a tail recursion. Do not get puzzled. It is similar thing. It is a similar approach. We are just calling the function at the end. That's all. We have already done two programmings in our topic 1. So don't get confused with the name. So if I take another example, like enter a number and finds the sum of digits, let me copy the program from here. Sum of digit, yeah, I guess this one. Let me copy it blindly. I hope it will work. Yeah. So instead of storing this variable, storing this value inside this variable, I can take this value without storing inside s, and after that returning s, I can simply copy that value here. So don't do this as a child, like do not store those values inside s and then return s. Instead of doing that, I'm returning that value itself. So it is also calling the function at the last line. That means it is also being called as a tail recursion. It is at the last line, I'm supposed to get the final value and I'm supposed to return the values. But here at the last line itself, I'm calling another function. So it will behave same. Okay. So if you not understand this problem, so just let me know via the comment section. I will try to manage something. So if I go to the topic 3, these are small topics. Suppose for series, obviously using this return function, will not be needed to print a series, because we are printing something. We do not need anything to be returned. If someone is asking to print a series like 3, 7, 11, 15, something like that, so we do not need to print the series, means we do not need the use of return statement in case of printing some series. Obviously, we do not need anything to be returned. But if anyone is saying like I need the sum of that series, then obviously I need some return statement. I can return the sum of those series to the main function. So here, if the program is like that, I can try to write the return type of recursion for this kind of program. So what I need to do, obviously I do not need anything probably from here, or I can return the value of n. I can write enter the limit. It is still 50, I guess. Yeah. So I can enter 50 and accordingly I will get the value. So here the sum, I can write a method name called series. Today I'm trying to take a good name actually. So it will be starting from 3 and then limit is n. And I will enter 50 anyhow here. So if I write series, the function name as series, and if I receive 3 as n, and here here suppose let me receive I, 3 as I, so I will be 3, and let me receive the limit 50 as n. So until the value of I is less than equals to n, I will try to run this program, and what I will do, instead of printing the value of I will return I plus series, the next turn I plus 4 and n. So in this type of program, do not think much. First, you need to control your thoughts. Do not think much. What I'm doing, I'm sending 3 and n. So I will receive the value 3, n will receive the value of n, that is 50. So until 3 is less than 50, I have to think about the end condition. And now just think about this iteration. Always think like about this iteration. So one famous man said like just think about today. Just think about today. What you will eat today, where you will sleep today. Just think about today. Do not think about tomorrow. So here I will follow that approach. Here I'm just taking the value from this run, that is I equals to 3. I have to take the value of 3 here. And after that, the rest of the things will come automatically. So I'm just sending 3 plus 4, 7, and it should return automatically. And when it will cross the limit, for a ending condition, I'm giving 0. Just I have to conclude somewhere. So as I am calculating the sum, so I'm returning 0 simply. So whatever I'm saying now, it is a key point to do the programming of recursion, you might ignore that part. But again, my suggestion is I always follow that way. Do not think about tomorrow, only think about today. So I am sending the value 3 as a first digit. So I want to return that 3 first. I have to think in that way. And the rest of the things will be managed automatically. Do not think about the full dry run. You will be confused. Just think for the next run, I have to send 7. And after that, everything will go automatically. So I am just sending 7 for the next run, and somehow it will be returned. If I can return 3, the next runs can also be returned somehow. So I'm just sending 7 and 50 here. That's all. My part is done. And I will simply run the program. Okay, do not think much if I go to the execution. So I want to get it printed till 50. So the answer will be 300. You can check in your calculator. So it will be same. Got it? So you have to think in this way. Okay. If I check another program of this type where somehow I need to think less, suppose sum of Fibonacci series. So we all know what is Fibonacci series. It is starting with 0 and 1. If I repeat once again, but I think it doesn't require any revise, but still Fibonacci series always starts with 0 and 1. So 0 plus 1, it becomes 1. Then 1 plus 1, it becomes 2. 1 plus 2, it becomes 3 accordingly. So here what I need to do, first I need to put the sum. I need to get the sum of 0. And automatically rest of the things will be calculated. I do not need to think much about the rest of the numbers. So let me show you how. So obviously here I need to write enter the number of terms because I'm not dealing with the limit. So n is the number of terms, suppose, and I will try to send two values, starting two values, 0 and 1, and n as a number of terms. So here I will receive int x and int y and int n. Int n is the number of terms. So in case of number of terms, if you have revised our first class, you are able to understand, like, until n is greater than equals to 1, I need to iterate this process. And what I do, first I will take the sum of x, only x. For the next turn, it will automatically happen. I will send y in place of x, and in place of y, I will send x plus y, and automatically everything else will be calculated. So that means I am receiving 0 and 1 here. Obviously 0 will not contribute anything, but still my responsibility is to return 0 plus rest of the series. For rest of the series, I am sending 1 and 0 plus 1, that is 1 and 1. For the next run, I'll be sending 1 and 2, kind of that. So automatically everything will be calculated. I just need to take care of where I'm ending. I am ending at n greater than equals to 1. So every time I need to send n minus 1. If I'm dealing with 10 terms, so this value will decrease. 10 to 9, then 9 to 8, then 8 to 7. Accordingly, it will run till the value of n is greater than equals to 1. We have handled this kind of if statement in our last class. Last means the first class of the recursion. That is the last class we have done. So if I compile and if I try to run this program, 10 terms Fibonacci series, the sum, I think it will be 88. Let me check. Yeah, it is giving 88 in return. So that means our program is correct. If you can check the program once again, I'm just sending the first two values with a n. So the use of n is very common. It will just calculate the number of terms. But here I am calculating x. I am taking the value of x, and the rest of the series will be done automatically. I'm not thinking much. Okay, so that's the idea. So now, if I go to the next part and the last part of the day, that is topic 4, and that is dynamic returns. So that will be important for our next class of the recursion, where we will try to solve some dynamic programmings. So dynamic returns means I have to think very wisely and I have to return very intelligently. So let me show you what I'm talking about. So suppose anyone is asking for the 6th term of the Fibonacci series. So if I use void first, how can I print the 6th term? If I use void, so again, I will be sending 0 and 1. If I'm trying to print void, I am trying to use a void function. if we are confident on our first class. Suppose, okay, let me first print the Fibonacci series itself. Let me print the Fibonacci series itself. So last two program for the day, and it will be a bit of tough, I will say, because we are entering into the dynamic programming, the world of dynamic programming. So here, what I'm doing, it is the way to print the Fibonacci series until 10 terms. We have done that in the last class. If you can remember, I'm sending 0 and 1, and every time I'm printing X. And next turn, I am sending 1 and 0 plus 1, another 1. And it will print the series of Fibonacci series until 10 terms. If I run, you can see if I enter 10, so 10 terms of the Fibonacci series will be printed. Now, if anyone is looking for the sixth term, so sixth term will be 0, 1, 1, 2, 3, 5. That means 6 terms will be 5. If anyone is looking for the sixth term, how can I fetch this number? So I will do one thing. If n equals n greater than equals to 1, okay, I will say like, how can I do this? Okay, I can do one thing. I can print the series until sixth term. So how can I do that? If I run this function, if I enter 6, so I will get the values until sixth term. So what I will do now, I'm not going to print all these 5 values. I will only print the 6 values, sixth value. Then only I can get the sixth term of this Fibonacci series. So what I will do, I'm not going to print any of the values here. I will go into the else statement and I will print the sixth term here. Simply, I will print the sixth term here. So I will iterate till n greater than 1. When n equals to 1, that will be printed inside else statement. And that is our void type of solution as per our class 1 of recursion. Okay, I'm writing a program with void. So instead of printing all 6 terms, I am printing first few terms here, and the last term, that when n equals to 1, that term I'm printing inside the else statement. So if I run this program and if I enter 6, I will get 5 in return. I should get 5 in return. Let me check if I have written the correct program or not. Yes, it is returning 5. I hope you are able to understand. If not, write me in the comment section. So I am taking 6 as input. Instead of printing the whole series, I have printed the whole series in the last class. Even I have written that program in this class itself. So now it is asking for, as it is asking for the sixth term, I am skipping all the runs. When n equals to 1, it will go to the else statement. I am printing only that term, and that will be good enough. But now for the dynamic approach, what I will do, I will not think in this way. I will simply print 0, 1 and n, or I will just send n. N means 6. N equals to 6. I'm sending just 6. So what it will do, it will just receive n equals to 6. If somehow n equals to 1, if somehow someone send 1, if someone wants to see the first term, the first value of the Fibonacci series, I will return 0 for him. If anyone is looking for the second term, that means else if n equals to 2. Think in this way. It is another way of thinking. If someone is looking for, okay, let me return int instead of void. So if anyone is looking for, if n equals to 1, if I receive the value of n1, that means someone is interested to see the first term or the first value of the Fibonacci series. So for him or her, I will return the value of 0. That is the first term or the first number of Fibonacci series. If anyone is looking for the second term, I will return 1 for him or her. And if anyone is interested for any other value, I will return series n-1 plus series n-2, that term. What does that mean? Suppose if I have sent 6 here. So obviously n equals to 6. So n is not equals to 1. N is not equals to 2. So it will go into this else statement. So what will happen inside that? Let me show you. It is not a normal way of programming. So you have to be very thoughtful, or you have to think differently in this case. So here for the value of 6, it will return series of 5 n minus 1 plus series of 4. So series of 5 means, just give me 1 minute. Yeah, actually, I received one call from my office. So anyway, an urgent call that I cannot skip. So anyway, so here return, I'm writing return series 5 plus series 4. So now what we'll do? Obviously, I do not have any answer. What will be the value for series 4 and what will be the value for series 5? So what it will do? It will do for series 5. It will calculate series. Okay, I'm writing S in short. S4 plus S3. And you can think it is quite obvious. The term number 6 will be the sum of term number 5 and term number 4. And that is the logic of Fibonacci series itself. So if I want to get the 6th term, it will be the sum of the 4th and 5th term. If I'm thinking about the 5th term, it is the sum of 3 and 3rd and 4th term. And what about the series 4? It is the sum of 3rd and sum of 2nd term. You can think in this way as well. So actually, recursion means it is another way of thinking. It is not a usual way of thinking. So S4 means again S3 plus S2. So it is called dynamic programming as well. So obviously, at the time of programming, you do not need to think in this way. Otherwise, you will be confused. But for the dry run, for the first time, I'm showing this to you. So S3 means S2 plus S1. And here S3 means again S2 plus S1. And here S2 means, you can see whenever the value is 2, I'm returning 1. So here S2 will be having a finite value, that is 1. And here S1 means 0 as per the programming. You can see if the entered value is 1, you need to return 0. So it will be 0. In place of S2, I'll be returning 1. So 1 plus 0, it will become 1. And S3 will become 1. Okay. In place of S1, again, it will be 0. In place of S2, it will be 1. So 1 plus 0, 1. And 1 will be returned to S3. Same. And here, S2 will be 1. And S3, again, it will call S2 plus S1. Do not think much for the day. Just try to grab this idea as an exercise of the day. So 0 and 1. So 0 plus 1 will be 1 again. So 1 plus 1, it will be 2. And 2 will be returned to S4. So 2 plus 1, 3. And 1 plus 1, that is 2. So you can think the 4th term of Fibonacci series is really 2. And 5th term of the Fibonacci series is really 3. And if I add these two, it will be 5. So the 6th term of this series is 5. We have already calculated that in the void way with a function which is returning void, but this time I have calculated that using a dynamic way. So this is a dynamic way. Got it? Just revise whatever we have done. Just think in different ways. So our number in Fibonacci series is the sum of last two numbers. Do not think much. Just think about today. So the 6th term is a sum of 5th and 4th term. That's all. That's all. And but this rule cannot be applied for the first term because first term is 0. The second term is 1. And for all the other terms, it is the sum of the previous two numbers. That's all. Think it in this way. And if you can think in this way, then you will be able to do the dynamic programming. So all the programmings we have done till now is is an example of kind of static programming. And if you practice more, if you do the exercise, that will be enough for you. But for dynamic programming, for this kind of programming in recursion, you have to think a lot. If you have, means if you can think in a different way, if you can think simply, if you can think simple, in the simple way, you are able to do this program. Obviously, we can do that. Just it requires some of the practices. Okay. So for the last program of the day, and it is another example of the binary search. So what is binary search? Binary search means, let me delete everything now. Probably I do not require anything. So suppose if I have a sorted series, sorted, it is arranged in an ascending order, you can see. And now, if anyone is searching some value, first I will show this program using the static way, and after that I will solve this program using the dynamic way. So suppose someone is searching 80. So what will I do? As per the chapter of array we have done, we need to search it one by one. If 80 is in this position, 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 80 is in this position. Yes, 18 is in this position. So that means it is 1. So that approach is being called as a linear search. But if the series is in arranged way, it is sorted. So I shouldn't go in this way. So suppose in dictionary is a place where all the words are arranged in an ascending order. So in dictionary, if I ask you to search water, so are you going to search it from the first page? No. From the middle, you will open one page. If your word comes after that, you will search only this place. And if your word, suppose you are searching, suppose cat. So your word, if it is coming before this part, before this page, you are going to search only this part. You are just skipping this part. So that is binary search. So here, if I'm searching 80, first I will go to the middle. So suppose it is the value of, suppose, low, and this is the value of high, the highest term. So low is 0. This is about the place, not about the value. The value can be anything. It can be 11, it can be 19. So it should be in ascending order. That's all. So the position is 0, and this position will be 9. So I will calculate the middle. Middle will be, suppose mid will be low plus high by 2. And it is an important question, binary search. You can solve it in both the ways, static or dynamic. So today I'm showing you a few programs which can be solved in both the ways. Both the way means it can be solved in both static and dynamic way. But in the next class, the third class of the recursion, will be few programs which can only be solved by dynamic approach. It cannot be solved by static approach. So today you have to understand what is dynamic way, and from the next class we will be using that dynamic way in full actually. Okay, so now if first let me solve it in a static way. So mid will be low plus high by 2. That means it will be 0 plus 9 by 2. That means 9 by 2 means 4.5, and it will be 4. So if I take the value 0, 1, 2, 3, 4. So mid will be somewhere here. You can see. So now if my value is greater than mid, then next turn, suppose 80 is greater than mid. So next turn, I'm not going to calculate from here. I will go directly from this position. So low will come into this position, mid plus 1. Because for the next turn, I'm going to check it in this part only. So all the parts before 50 and 50 will be skipped. So an array of 200 elements on the first turn, after the first turn, either value is found or not found, I can discard 100 elements. So this binary approach will be quicker. So I will take another class where I can show you like the time complexities of different approaches. So why binary search, or why the linear search, means why linear search is complicated, or it will take more time than binary search. I will explain all those things here in that class. Okay, but today just try to understand that logic. So next turn I will try to calculate I will try to find that value here. Okay, so now again I'm trying to find 80. I will calculate the mid. Mid means 5. This is the fifth term. 5 plus 9 by 2 means 14. 14 by 2 means 7. So mid will be somewhere here. So if my value is equals to mid, yes, it is equals to mid. That means I can say found. So just by 2 iterations, I got this value. If I want to follow the linear search, I have to find 8 numbers, 8 elements I need to find. 8 iteration will be there. So it is fastest. Even suppose if you are going with a value that is not there, suppose 85 I am going with, then also it will be quicker. For 85 in linear search, you have to find all 10 numbers in the array. But here, let me show you how many times I have to iterate to find 80, 85, to say like 85 is not found. So here I am again checking. Okay, let me search 75. So this time 75 is in the middle position. No. So 75 is lesser than 80. So what I will do, I'm not going to check this side of the 80. I will check here. I will be come to this position. So let me write only H. Let me write only L. So that will make sense. So now my array is being sorted into these two positions. So I will again search L plus H by 2. That is M. And that will be, M will be in this position. So again, I will check. 75 is this one. I will say no. So L will be M plus 1. So L and H both will be in the same position. Now I will search again in the M. L plus H by 2 means it is the position. And I will search 75 is 70. No. If no 75 is greater than 70, then L will be going to this position. I will do all those things until L is less than H. Less than or equals to H. If the lower limit crosses the higher limit, that means we are done. The 75 cannot be found in this array. So I took 4 iterations to say 75 is not present. In case of linear search, it took 10 iteration. Okay, just give me 1 minute to plug in my charger. I know it is becoming a longer class. I can understand that, but still, this is the last topic or last question I want to make you understand. So the simple logic is, okay, let me write the logic first. Then I will try to explain this once again. So suppose, let me take an array. Suppose let me take the array. I'm not taking any input. Suppose let me take an array like int a, and let me take a simple array 10, 20, 30, because if I want to take the input, it will take a hell lot of time. So let me take the array like this, and I'm trying to find a value called val, and that is I'm taking 80, say. And what I will do, without using any use of function, I can do this. So what I will do, let me delete all this thing. Quickly, I will write the first position, that is the lower limit, that will be 0. The highest position, that is high, that will be a dot length minus 1, that is 9. And I will iterate a while loop until the value of L is less than equals to H. That's all. So here I will say like Boolean found equals to false. So whenever I got the value, I will change this found variable to true. So what I'm doing, what I will do first, I will calculate a variable called mid. That will be L plus H by 2. I'm trying to find the middlemost position. I'm not taking care of the value. I'm just taking care of the position. So lower limit is lesser than higher limit. And I'm just calculating the middlemost value, middlemost position. So first I am checking if somehow the value at that middlemost position is equals to val or not. If it is equals to val, I will say it is found. I am very lucky and it is found, and I can break the loop. That's all. We are done. And if it is not found, I will check. Let me explain once again everything I have already explained, but let me re-explain those things. If the somehow the value is greater than value I am finding that is greater than the value in middle position. If it is greater than that, what I will do? I will just write the lower limit will be now middle plus 1. I do not need to take a look into the first part of the array because the value is greater than value is in a sorted order and value is greater than middlemost value. So I do not need to take care. I do not need to take a look into the first part of the array. That's all. And if the value is lesser than the middlemost value, what I will do? The higher position will come like mid minus 1. That's all. And it will keep iterating like that. Okay. And at the end, when if L crosses H, then the loop will be stopped. And I can say like the value is, I can print our Boolean variable and it will print accordingly. So if I write found or not, so it will say true or false. If I run this program for 80, I have given all the inputs inbuilt. So it should print found equals to true. You can see. And if I change the value inside, suppose I'm giving 85. So 85 is not present here. Or let me give 75. 75 is not present here. So if I run, it should print false. Yeah, it is printing false. So this is the way of binary search, and it is important program for the interview round as well. And it is quite simple. You have to iterate the loop until L less than H, less than equals to H. If you find the value at the middle position, then you will say, yeah, got it, found. If the value is greater than the middlemost value, you will place the lower limit at mid plus 1. And if the value is lesser than the middle value, obviously you do not need to take a look into the second part of the array, and the higher position will come as mid minus 1. That's all. So if I compile this, and it will work. Now, if I want to do this in a dynamic approach, what will I do? I will just use some function here. Instead of printing the found, I will just call a function called binary, and I will send 0. I will send a dot length minus 1, that is H, and I will send the value I'm trying to search. So let me delete all this thing. Okay, and obviously I need to send the array as well. That is A for array, that is the lower limit, that is the upper limit, and that is the value I'm trying to search. So now if I create a function like public static void not void, suppose Boolean binary. So let me take the array input here, int A, suppose, and here suppose L as 0, H as 9, or whatever the limit of that array. So H, what else I can take? I can take val, kind of that. Okay, sorry, I have to take int L, I have to take int H, and I have to take int val. So if I check if the same logic, if L less than equals to H, and okay, I have not copied that. Anyway, if L less than H, I will calculate the mid, that is L plus H by 2. The same thing. If the val equals to A mid, then I will say we are done. I will simply return true. That value, I found the value. Else if the value is greater than A mid, then what I will do? I will just write return, and I will call the same function binary with the same array. In case of lower limit, I will give a new lower limit because value is greater than the middlemost value. So lower limit will be sent as mid plus 1. And I will give the same higher limit, and I will give the same value. And else, if the value I am trying to find that is lesser than the middlemost value, what will happen? I will send the array. The lower limit will be the same, and the higher limit will be mid -1. And the value I'm searching will be same. So if I run, what is it saying? Okay, I am missing one bracket. If I run missing return statement L plus L greater than H, else I will return, suppose somehow L crosses the value of H. So it will go into the else statement and I will return false. Means I couldn't find the value. So if I run this program and I'm probably sending, it is saying false because I am sending 85 probably. Yeah, 75 I'm sending. If I send 80 now, it should return true. Let me show you. It should return true. Yeah. So the same approach I am doing twice. First using static approach and next time I am using the dynamic approach. So class is getting longer, probably the highest class till now. So if you are not able to understand the binary search for the time being, skip this. But you until the Fibonacci series, that dynamic program number 1, until that part you have to be very clear with. Because in exercise, you do not need this binary search until the knowledge, until the Fibonacci program will be enough. But yeah, anyhow, next day on the next class, we'll be entering into the chapter of dynamic programming. So this is the way, this is few examples of the dynamic programming. But the advantage is for this dynamic programming, we have another alternative approach of static programming. Okay. So here, but from the next class, we do not have any static approach anymore because all those programs can only be solved by dynamic approach. So anyhow, you can go to the chapter, you can go to the exercise and you can try to solve all those exercises using return type this time. Okay. You can go through this chapter if I share the details. The same chapter, the same exercise that you have solved of recursion from the album coding exercise basic, if you go to this Facebook group. So the same exercise that I have suggested for the void type, you need to solve the same, this time using the return type, something you will return, the same exercise. Just get used to with this recursion approach and next day we will jump into the dynamic thing, dynamic programming. So that's all for the day. In case of any doubts, just let me know. And yeah, just practice all those programs I have shown. Must practice, must, because that is mandatory. Otherwise, you will not be able to understand anything. Okay. In case of any problem, let me know. Bye for the day.